don't just tell me on decimals, like, I wrote this times that or whatever. I want you guys to go ahead and specifically tell me what is that you did. Not just show me the work. So again, if you're thinking about it a certain way, tell me this is what I use, this I need. Make sure you guys also show the work on your whiteboard because you're going to show your partner in a bit. So erase it, leave it on there. Whatever it is that you did, make sure you guys leave it on there. And erase it. Okay, give it seconds, 5 seconds. Alright, we'll start with B. If you're a B, raise your hand. Who's B here? Who's B? You're A. B's. Go ahead and tell your partner, show them your whiteboard and what you did. You have 15 seconds. A is going to tell your partner what you did. Show them your whiteboard. Alright. DeAndre, can you say what you did?
What I did was I plugged in 4 and -4 as x, and I knew that if I plug them in the x, they'll be have an exponent of 2, which means they'll multiply by themselves. And I knew the x would be 16.
Yep. So he said he plugged in, and says the exponent is 2, that means it's multiplied to itself twice, and it gives you 16. Let's see. Jeffrey, what else did you do? How did you solve for this?
I started a square, you do square root, and then you do the other side, and then
Alright. So he's saying, I know that to get rid of a square, I could do square root to both sides, and my answer is 4. Now, he also said -4 times -4 is also 16, correct? So what's missing here? Ooh, -4 as well. Now, do you guys recall from our study guide, what goes in front of a square root? What are the 2 signs? Go ahead and talk to your partner. What are the 2 signs that go in front of a square root? Talk to your partners. Yeah, the square root. And for, based on your answers that you guys just got, what are the 2 signs? What are the two answers that you guys got, you guys? It was positive 4 and negative 4. So therefore, the two signs that go in front of there are what, Joseph? Plus and
Oh, yeah.
minus. You guys remember that from algebra 1?
Yeah.
Whenever you take the square root of something, you have a positive and a minus, because a positive times a positive gives you a positive, and a negative times a negative also gives you a positive. That's where you get two answers. Are we good on that?
Yeah.
Cool. Alright. This right here is what you guys need on your paper. It's on decimals, but we will not type this until we're done. So I want you guys to go ahead and use the paper where it says slide number 4. So put everything else aside. Grab the paper. Look under slide number 4, you guys have this exact same table. You guys can use any of the strategies that we just talked about to solve for these. Some of these you guys cannot solve mentally or simplify, so you'll have to leave in terms of a radical. And you'll see what that means when you guys try it. So go ahead. Attempt them, attempt them, attempt them. On your paper, Santos. Attempt it on paper. There's the first table. We talked about a couple of strategies that we just did in the warm-up. Use that to figure out the answer for all of these. If you guys cannot simplify, remember you guys can leave in terms of a radical. You don't need to calculate that. Radical just means you can calculate it. So make sure you do it just like this. So there will be you don't need a calculator at all? Trust. Be careful. You want to get the strategy we use? Stays as is. That's what that means. Alright, go ahead and turn to your partner, share answers, and figure out. Do you guys have the exact same thing? Are you missing something?
Oh shit, my bad.
So again, check with your with your partner, the answers, Joseph and Santos.
I don't remember the cube. I don't remember it. I just remember it. I don't know the fourth one. No, I don't know the fourth and the second one. Shit, how you get seven? I don't know how you have those things.
Alright. I feel like all you guys got the first one, right? That one's easy, right? You guys could have done either method. What was the answer? 5 and -5. How do we get rid of a square? Square root. What's in front of a square root? Plus and minus. Therefore you get? You get two answers. One's positive, one's negative. For number 2. What does it have right here at the top? The 2. So how do we get rid of a square? Square root both sides. You guys know the square root of 7? No. So therefore you leave it in terms of a radical. Square root 7. Now something's missing. Back to this. A negative and a positive. So positive square root of 7 and negative square root 7. Make sure the negative is in the front, never in the inside. Okay? The third one, you guys could have thought about this mentally. Michael, what did you get for the third one? Oh, do we agree? Why do we not agree for that?
It's 3, so it's not, yeah, it's 3, it's 2.
So 2 times 2 times 2 gives us positive 8. But does it work if it was negative? What would that give us? Negative 8. So does that work? So in this case, when it's cubed, or it's a power of 3, how many answers did we get? One single answer. So what do we predict for the last one? How many answers will I get for the last one? 1 as well. Alright. For the last one, we have w to the power of 3 is equal to 19. What's your exponent in this case? 3. So can I do square root? Absolutely not. This right here is what we call a radical, you guys. It's a radical when you guys want to use any type of root. Now, this one was square root because my exponent was squared. This one, it's a cube. What's the name of this one? Cube root. So I'm going to do cube root to both sides. So if you guys start to notice, your exponent matches the root. So again, your exponent matches the root. Do you guys know the cube root of 19? Absolutely not. So that means you leave it in terms of a radical. Cube root of 19 is your final answer.
With 3 or no?
Yep, I'll show you guys how to find out right now. I need you guys to go ahead and, let's see. I'll show you guys right now really quick. Make sure you guys pay attention and we'll even show you guys once. So for this one, it was positive and negative 5. This one, it was square root, right? Go ahead and type SQRT. And you have square root. Again, SQRT. And you have a square root. Go ahead and click the little arrow next. And you got 7. Make sure you click next, and then you do the little comma. And then negative.
What's the next answer?
Little arrow.
Oh, yeah.
And then SQRT, 7. There you go. Now for that last one right here, you need to open the keypad. I'm only gonna show you once again. Open the keypad. And at the very bottom, you guys see this right here? That right there is a radical for any type of root. So this one right here. This one is square root. This one is for any other root. Does that make sense? So again, when you don't see a number in the front, it's always square root. This right here is for any number, for any roots. So that's the one we are going to use right here. And now you guys see that it lets you type a little number in the front, and then it lets you type a number in the inside. And now you have a cube root of 19.
Can you go back to the second one? I'm still saying it wrong.
Maybe it might be a little
yeah,
space.
outside.
Yeah. Yeah, the negatives always go on the outside, be careful about that, there's no such thing as taking the square root of a negative number. If it shows wrong, it might be a little extra space. Are we all good? You guys all type them in?
I'm lucky there's something wrong. Your second one, I was thinking. Because this is smart, that's what it is.
You put the column in the square.
It's alright.
Hey, bro, no problem, man. Bro, what are you doing? I swear.
Is there an extra space or something?
I'm not sure.
It might be.
Go ahead.
It might be the extra space after the comma, don't do the space after the comma, that's it.
Grab it, man.
Hurry, cause I'm gonna move you guys. Sorry.
You got 30 seconds, bro. 10 seconds.
Go, go, go.
No, Miss Nutt, that's what Miss Roddy took.
It's fine, just do it like that. So right now we're working with radicals and we're working with exponents, correct? I want you guys to remember that. You're gonna make a prediction right now. So Claire said that 9 to the power of 2 is 9 times 9, which is what, you guys? 81. She also said that 9 to the power of 1 is just 9, correct? And then 9 to the power of 0 is 1, because any number to the power of 0 is always 1. Now they're saying, well, make a prediction. What do you guys think 9 to the power of 1/2 might be? Go ahead and type in your answer. So again, remember we're working with radicals, we're working with exponents. Look at this list. 9 to the power of 0 is 1, 9 to the power of 1 is 9, 9 to the power of 2 is 81. What could potentially 9 to the power of 1/2 be? Make a prediction, just tell me how you know, or what you think. fine, we'll talk about it to make a prediction right now, that's all you need. Again, consider what we were talking about earlier. You need to know. Again, we were using radicals, we were using exponents. Consider, looking at this list, whatever prediction you made, would it fit into this list? Alright, in this case, go ahead and ace. Go ahead and turn to your partner, tell them what you wrote, you have 10 seconds. Ace.
Oh, you're right.
B's, turn around. What did you write? Is it again? It's not similar, you have right
Wait for it.
there. The last part you got.
No. Don't be changing.
Alright, Arvella, what did you guys talk about? Good, so, I know it's between 1 and 9. So that's true.
Sorry.
Okay, and any students are absent, if you go to this, hold on to it. Thank you.
Alright, so again, back to what Marvella said. Since 9 to the power of 1/2 is between 0 and 1, then maybe our answer has to be between 1 and 9. Can you add to what you said right there? What did you, think about?
I thought it was 3 because it's a multiple of 9.
Okay, so he's saying, well, now we're thinking about multiples of 9, so potentially 3. And then Joseph, can you add on? But specifically what you wrote right there on your screen. Alright, so he's saying it's probably the square root of 9, which is actually 3. And it has to be a number that's a multiple of 3 as well, right? So maybe it's 3. Some of you guys were saying it's half. And I saw some of you guys were saying it's 4.5. But does that number 4.5 make sense within this list? What is it doing every single time? Multiplying, right? So if you were to multiply 4.5 by itself, 4.5 times 4.5, would you get a number that's related to 9? No. So just keep that in mind. So again, you made a prediction about what this might be. And then we'll look into it, let's see, sorry guys, let me pull screens. Alright, so now we're gonna use a graph and see what happens. So I want you guys to go ahead and type in the function, the actual equation itself. They have a function y equals 9 to the power of x, so go ahead and type it as is. Y equals 9 to the power of x. And you'll get this little line right here. You'll get the graph. Do you guys remember input output? Yes? In this case, which one's your input? The x, and which one's the output? Y. Alright. Go ahead and grab your whiteboard really quick. Does everyone have the graph on their screen? Yes? Alright. So recap of unit 1. Go ahead and tell me what type of function is this? What type of sequence is this? And how do you know? Go ahead and write it. Quick little review. Quick little review.
What's the number? What's the number?
Go ahead and write it.
What's the next one?
What type of function? What type of sequence? If you're trying to remember, right? If you guys forgot the names, you guys can see the posters over there in the back, right? And then if you guys need a little support for your reasoning, think about this list right here. I need you guys to write something, even if you don't know the name. What can you identify from the list? What's happening in that list? Need something on that whiteboard? I'm gonna give you guys another like 20 seconds. And if it's this, what's happening? What was that last part? That one is. Someone just asked me. Yeah. Go ahead and show me your whiteboards. Good, let's talk about it. David, what is it? It's geometric because what? Okay, so we know it's geometric because it's not a straight line and it's rising. Specifically how, Dave?
Rapidly.
Very rapidly. Let's see, what else? And it's increasing very rapidly because what is it doing every single time, Lucia? Because it's multiplying every single time, right? So therefore it increases very, very rapidly. Do you guys remember what this right here is called, this number 9? The growth factor. The growth factor, and then the exponent always represents time. Time. The amount of times something happens. Good though. Alright, we're gonna go ahead and use the graph now. Make sure you guys put the whiteboards to the side. Alright, so remember, which one is your input? X. In this case, if I have 9 to the power of 1/2, what's my input? 1/2. What is 1/2 in decimal form, you guys? 0.5. So go ahead and identify 0.5 on your x-axis. And go ahead and meet the graph. Click on it. What's your answer? Yep. So what's your output? 3. Go ahead and type in 9 to the power of 1/2 right here. And what's your answer? 3. 9 to the power of 1/2 is 3. We see that on the graph, we see that here. We kind of made a prediction about it earlier, right? So I want you guys to go ahead and think about it. Now that you guys have seen the graph, you guys made a prediction as well on slide 5. Go ahead and tell me, was your prediction on slide number 5 correct or incorrect? And now that you guys actually know what the actual value is, what helped you guys figure it out? What is it that we did right now that helped you guys figure out the true answer? Or what helped you figure it out then? Vanessa, were you correct or incorrect at the beginning? Okay, and then as we moved on, what helped you figure out the right answer? Okay, so she said it was incorrect at the beginning, but the actual graph was what helped her figure it out. Good. Some of you guys were able to infer this earlier on, right? So your prediction was correct. What was the answer? 3?
Trace.
Yep. The correct answer is 3. So 9 to the power of 1/2 is 3. 3 is, in fact, a multiple of 9. Alrighty. Moving you guys on to the next one. Alright. Go ahead and grab your whiteboards really quick. And then we're gonna reference the actual right? In the warm-up, we had 4 times 4 is equal to 16. This is the same base, correct? Do we have an exponent? Absolutely. What is it? 1. 1 and 1. Now, when I have the same base, what happens to my exponents? They add on. So it's the same thing as 4 to the power of 1 plus 1. And 1 plus 1 is what? 2. You guys remember that? So again, same base. What happens to the exponents, everyone? They add on. Go ahead and show me this process right here with this example. Go ahead and show me that on your whiteboards. 9 to the power of 1/2 plus 9 to the power of 1/2. Go ahead and show me that you guys know how to simplify this. So simplify it the long way, that's alright. That's what I want you guys to do. That's what I wanna see. Simplify it in this way. You'll see why I asked you guys to do that. I think there's a little. So we're choosing this way. This is what you should have showed me. Right there. This is what I wanted to see. Okay? So I know that I can simplify it in a way that it's just 9 to the power of 1/2 plus 1/2. What is 1/2 plus 1/2? 1. And what is 9 to the power of 1? 9. So whatever 9 to the power of 1/2 may be, so again, in order for us to get 9, what is the actual value of 9 to the power of 1/2? Go ahead and type it in. Alright, everyone, what was it? 3. Because I know that 3 times 3 is equal to 9. Okay? Before we do anything, I want you guys to go ahead and answer this right here. Make sure you guys are ready to explain and share out. So, now that you guys figure out what 9 to the power of 1/2 is, which is 3, I also know that square root of 9 is 3. The same way that 9 to the power of 1/2 is 3. So what can you guys conclude about fractional exponents and square root? Go ahead and write your response. I'll give you guys about 45 seconds. Go ahead and write your response. So again, if square root of 9 is 3, and 9 to the power of 1/2 is also 3, what can you guys conclude about this fractional exponent and the square root? Wanna go back to this one? No, you are. same with the Santos needs to go back to this. Perfect, David.
That's like, that should put it
Good, Michael. Finalize your answers, you guys? Fewer seconds?
Yeah, I think you can go back to this one, bro.
If God allows it, we can say, you're not gonna need it pretty like that.
You said inward? What? That's not what I said. I said something like weird. I don't care about you, bro.
Oh, yeah. Sorry, perfect.
Okay. Alright. Vanessa, can you read what you wrote, please?
We can conclude that the action is completely times square root gives us the same answer and are equivalent.
Okay, so she said we can conclude that fractional exponents and square roots give us the same answer. So therefore, they should be equivalent, right? Can you add on to that, Michael? Okay, so he said, well, they probably have the same properties in terms that if you're multiplying 3 times 3, you get 9, right? So they're all multiples of 3, 9. So, David, what did you notice? He said the denominator of this fraction is the same as the actual root that we're using. In this case, they use square root. You guys see that number 2 right there? So he's making connections between those two. He's saying, well, I see it in the denominator, and I also see it in the root. And that is very true. You guys will see how we use one of the others to rewrite them. Because yes, in fact, you guys can use fractional exponents and turn them into radicals, and vice versa. Good. Alright, so we're gonna go ahead and move on to a new scenario. I want you guys to go ahead and same thing right here. We have a different type of problem. In this case, you guys, what is your base? What's your base? 3. So go ahead and type in the equation y equals 3 to the power of x on section A. And you'll see the graph. Again, what type of graph is this, everyone? Exponential. Good. They want you guys to estimate 3 to the power of 1/2.
Please pardon the announcement. Students, if you are going on the field trip with Miss Tavega, please meet her on the D side. Once again, if you are going on the field trip with Miss Tavega, please meet her on the D side. Thank you.